Hi everyone, my name is Shrey Anand. I am a data scientist with Red Hat, and today I'll be talking about key performance indicator metrics for the OCPCI analysis project. So I'll give you an overview of the project and why we need these KPI metrics and how we can write them. So the broad idea of this project is that we want to have AI supported continuous integration. And by that, I mean that the continuous integration process involves running automated builds and tests of software before it is merged into a production code base. And we collect data from these automated builds and tests, which is called the test script data. And um, using this raw data, we write some performance indicator metrics that tell us about how the how the overall CI process is performing. So, um, for example, if we develop an AI tool that somehow uh, supports this process, then these metrics will help us know what the actual impact of that tool is on the process. So, uh, a major part to note here is that the test script data is real time, and as we have more project builds, we have the results of these automated tests, and these metrics have to be updated real time. And for that to happen, we need an automated pipeline that we already have in place. So when you are writing a KPI metric notebook, you don't have to worry about the automated pipelines. You just have to follow certain conventions. And if you do that, it can be easily plugged into the pipeline. And then it's a very important contribution in that part because we have the KPI metric notebook and we can easily put it into an automated pipeline. So let's go to the notebook and data sources, test grid, metrics. So you can read about the existing KPI metrics here, and we have written a few of them already. Um, for now, I will go to the metric template notebook, which has all the sets of conventions that we need in order to write these KPI notebooks. Before I do that, I'd like to take you to an issue which talks about what we are going to implement. So it's always a good practice to create an issue first, and then people in the community usually upvote it and then try to refine it. Once we have that, we can start working on the notebook. In the issue, we are trying to describe what we are going to do. So here we say that we want to see the percent of tests that are flaky updated weekly. And we also try to specify how we are going to implement this metric. So once we have this issue and we know that we want to work on this, let's get onto the metric template notebook. Um, so we start with a header here that lists the metric name. And for example, we have the flake metrics. And then in the description, we write why we want to implement this metric and also all the subtypes of these metrics that would be covered in this notebook. So for example, percentage of flakes on platform each day, percentage of flake by grid each month, severity of flakes, and so on. At the end of the header, we also link the issues. So issue 1 is the same that I showed, and issue 2 is another issue that is covered in this notebook. So Once we have defined the header, we can move on to importing libraries. Um, these should be enough for most of the work, but you can also import more libraries if your metric requires that. Then we move on to specifying variables. So um, a point to be noted here is that, like I said, we want these metrics to be run in automation. We have to specify certain variables that will make sure that that happens smoothly. However, if you want to work locally while developing these metrics, you don't have to worry about the automation variables. You can just specify the input data path, which is the example data in this repository. So when you clone this repository, you will get this example data, and you can just work on this. This output data path is obviously the place where you would store the computed metric. Um, and then finally, the Ceph variables here. The Ceph variables are required for the automation pipeline to get the data from S3 storage. And you can have an environment file in your system to, if you want to test how the automation would work. You could also specify these environment variables in the spawner UI of Jupyter Hub. And you need to also have this automation variable here, which specifies whether or not your notebook would be run in an automation environment or in a local environment. I have this example open here of the environment file. It would look something like this. Simple assignment, and then you can just load it into the metric template notebook. So once we have the uh, variables set, we can move on. The next class here is the Ceph communication class, which would help you to establish communication with Ceph3 bucket. So it'll connect to the bucket, it can upload data to Ceph, and it can read data from Ceph. And you would need this when you are writing code for automation pipeline. Similarly, you have save to disk and read from disk, which would save your data to disk and can read the data from disk. Finally, we import the data. So if we are running this in automation, like I said, we'll use the Ceph communication class to connect and then read the data from the Ceph bucket. And if we are working locally, we can just read data from input data path. So you could either use the example that's already there in the repository, or you could use the get raw data notebook to pull your own data and then use that as experiment data here. So once we have imported the data, we can go to the next cell that has a lot of helper functions. So we have the decode, run length, and test script label wise encoding and test status class. So basically, the raw data that we get from test script is run length encoded, and often when you'd be computing metrics, you'd need um, to unroll this data and have a nice data frame which can be used for computation. So these functions would help you to do that. And finally, we can start calculating the metric. So we unroll the data set here, we print the data frame, and as an example, we are taking the flake severity here and calculating that. So we have tests here and then flake severity here. In the next section, we try to visualize it. This is optional because we don't need this in automation, but it's a good exercise because we can see what the metric is actually computing. So we have the visualization here, and then finally we save results to Ceph. or locally, depending on how we are working. So if this is an automation, then we use the Ceph communication class to connect and then upload to Ceph. If it is not, then we save to disk. We can also do a sanity check here to see if the data that we are actually saving gets to the right location, and then it's working smoothly. So once that is done, we end this notebook with the conclusion section that reports the status of the calculation, highlights any difficulties, and adds any side notes and future efforts. So that's pretty much it. Let's go and look at an example of a metric notebook that takes this um, template and then computes the metric. So the quantify flakes metric here specifies the header and everything that's going to be computed in this notebook, and then imports the libraries that are required. So you can see that here we have imported all the helper functions directly from the metric template notebook so that we don't have to rewrite these functions. Um, and once we have that, we specify all the variables, the Ceph environment variables. We import the data and we go on to the calculation, severity metric, we do the visualization, and finally save results to Ceph locally. So yeah, that's about it. I hope that this video was useful and it lowers the barrier for you guys to contribute to this project.